Okay, welcome everyone to the final panel session of the day on metadata for data governance, what's linked data's role. In terms of the drivers for this panel, obviously you've heard a lot from the earlier presentations today about the increasing use of standards and technologies and approaches such as DCAT SKOS, Schema.org, CSVW, both for managing internal metadata for data governance, also GDPR compliance, and other requirements. So really this panel is a chance to speak to the experts about how they're using these technologies, these standards, and really how you use them to start to address some of the kind of data governance challenges that we all face in our organizations. So I'll start off with a kind of introductory question for the panelists. Hopefully each panelist can perhaps start with just an intro as to who they are, their background, where they're from, and then a quick statement around what does data governance mean to you?
Thanks, James. Okay, so I'm Eugene Morozov. I work for a company called Lab 49. We're a consulting firm focusing on capital markets primarily. My background is software development, so I've been doing it for quite a while. And I think definition of data governance that I find particularly useful is it's really just exercise of authority and control over your data management. And the reason I like it is depending on your project, you can look at that from different angles, be it software development or anything else.
Hello, I'm Paraskevi. So basically my experience with data governance comes mainly with my work in JP Morgan and Chase around providing reference architecture and standard vocabularies, and also on building an enterprise data governance platform where we could basically govern data and metadata for the whole technology. So with regards to what is more important with regards to the terminology of the data governance, I think data governance is more about having the right processes in place in order to manage different data assets. So these data assets may vary based on the domain and let's say the business domain. And it's also about understanding the data you have. And also putting controls around that, as Eugene mentioned. It's also about thinking of these processes and as something that evolutes as your data evolutes, and the requirements around the data and the data integration requirements also evolve. And it's also about having data governance in place to provide accountability and trustability as an organization around your data assets. So, thanks.
Hello, I'm Mandy Chessell. I'm a distinguished engineer at IBM. I worked for the company for over 30 years. So I've seen from centralized mainframes all the way out to very distributed systems, and worked always on distributed processing. So how do you get multiple computers to collaborate effectively, which is becoming less and less of a challenge, although we have more and more computers and more complex processing. So data governance to me is really about what do you have to do today to get the maximum value from it? And there are many different perspectives on what value means, and many different sort of requirements around it. So I think it's an ecosystem. It's definitely got all the pieces that we've talked about, but it's also about focusing on the value that you get from an individual perspective. So no one should have to put stuff into governance that they're not getting anything back.
Hi, I'm Aaron Bradley, Electronic Arts. I'm the non-engineer foil to this panel, so ask your clever questions of them. With that dumbed-down view, my view of data governance is having confidence in a source of truth within a data ecosystem, rather than wondering if there's other data points out there that are ungoverned. Yeah, we'll
Just, yeah. Okay, it's very, very interesting. Different perspectives on what data governance is. I guess maybe starting with a bit of a negative. So rather than talking about the opportunity, obviously some of these technologies, data governance isn't a new thing, but some of these technologies and these standards are new things that are being applied to data governance. And obviously part of that has come from a failure of traditional data governance approaches, which have started, I guess, in the 80s in areas like data administration and been taken under the wing of data architecture and data modeling and other areas. I guess maybe this might be a question for Mandy, given the talk that she gave earlier. But what would you place as the kind of main reasons for why traditional data governance initiatives have generally failed in a lot of organisations?
I think most of them were associated with the data warehouse. And the data warehouse was trying to create a single perfect view of how the organisation was operating. And given that the organisation is typically operating in a somewhat haphazard and less than standard way, there was a lot of manipulation that was required to the data to create that single view. And what happened was that the governance processes were all about pushing the consistency back into the source systems. And so it was perceived very much as a process to prevent innovation, to create standardization when it didn't exist. So it was always the effort was being pushed to the people who were not getting any benefit from it, because it was the downstream users of the warehouse that got the benefit. So you had a constraining, expensive set of actions that were required of people who weren't getting much value. And so you can see that that is a very uneven spread of effort, and unless you have regulations forcing this, it's very difficult to enable that in a modern organisation.
Anyone else has a perspective on past failures? No? Okay. I guess maybe I'm fairly picking on Paraskevi here, but one of the things I found really interesting about your talk earlier was you were talking about lots of traditional approaches to modelling alongside newer linked data semantic approaches. So you talked about physical data models, logical data models, possibly there was even a conceptual mention in there. How do you find you're able to reconcile these kind of two tribes? Because I guess there are still two communities out there, or at least two communities, if not more, with very different perspectives to how you document metadata, how you model data, the different standards that you use for interoperability and so on. I guess that was one thing that I found really interesting in your presentation.
So with regards to the use cases about metadata we had within JP Morgan and Chase, we had logical and physical data models. And I would say, this is coming more from the traditional warehouse kind of work, where you're trying to model each and every aspect of the domain, the business domain you have. So the idea is, by using semantic linked data technologies, basically you could bring all these different artifacts in a common representation, such as RDF standards, and then as long as you have RDF, let's say, it's much more easier to do analysis and validation on top of your whole data sets and metadata, because you could more homogeneously apply rules or run analysis measures with regards to the quality, the retention, the lineage, etc. So I think it's quite valuable. The language, like the standard, the standard itself, RDF language, it provides this ability to basically unify the different formats, and also unify the variety of domains you may have, because it provides easily this linkage between the different data or metadata. And the other thing is the semantic linked data paradigm itself. basically already has other standards that solve issues around, for example, data governance, such as the Provo ontology for the Provenance and Data Lineage, or within finance, we have Findbow standard, or in the healthcare, like life sciences and Elsevier, we have SNOMED. All these things have been basically built around the semantic web technologies and standardization. So this makes it quite handy.
Well, probably to add to that, so definitely the biggest value for me for software development, it's the availability of existing ontologies for things like, so you mentioned Provo for provenance. There are lots of other standards that can be reused, so they don't need to be reinvented. And I think some of it, specifically with relation to data provenance and data lineage, will be especially useful for implementation of some of the regulatory reporting, for example. Very soon, companies will actually be forced to look at the data issues and try and resolve them on a fairly short notice. And that's where data lineage, data provenance will definitely help. Storing that metadata with your data, having the ability to visualize it, analyze it in the same place. Maybe.
What are those standards for provenance that you're using?
So, for example, Provo. I guess the beauty of it is that, maybe I can expand a little bit on that. So the beauty of that is that everything that you work with can be stored in RDF. So you'd be storing, for example, validation rules, you'd be storing provenance metadata, you'd be storing metadata about your data sets as well, using something like DCAT or using CSVW. And it becomes really, really useful. So everything is in one place.
I guess that ties quite nicely into another question. So obviously, in the semantic web linked data world, adoption is quite a commonly discussed theme, so to speak. And the challenges around, making these standards and technologies easier to consume to a wider audience. I guess one of the things that we've touched on in lots of different areas today is, how things like schema.org are making it easier to start to get up and running knowledge graphs. It seems like a lot of people that are perhaps starting to get involved in this space are starting actually with metadata because it's lower volume. It tends to be things that people are familiar with for using these technologies. I guess what do you think would be your advice in terms of a minimum viable product or the easiest thing that someone could do to get started with using these in their organisation, these technologies, these standards? What would be the easiest place to start with?
I think things like schema.org that allow you to consume common definitions of terms. Because one of the things that's critical when you're sharing data is to actually agree on what the data means. People are not very good at creating definitions, and a lot of glossary projects or ideas of common definitions falter because people find it very hard to be precise. If you can find an ontology that's already created that actually works for your organization, you're really going to save a lot of time. And it becomes almost an impartial referee between arguments between different parts of the organization where a term is very similarly used but has a slightly different meaning. So if you can say, well, actually the standard is this, so let's map to that. So I think from helping people get started, providing a framework that people trust, I think the ability to be able to download a standard ontology is a really good starting point.
Yeah, agree with all you say, and I think at a more general level, simply aligning on terms and having that framework that allows you to do that in a consistent fashion. And to what was said earlier about the data warehouse, right? the reality, insofar as we have aligned on a definition of knowledge graph, one of the value propositions there is it allows you to use data from heterogeneous sources and reconcile that. And the reality of, particularly in big organizations, is that data resides in many different silos. And it's more efficient and meets the realities of the organization more to keep it, if it makes sense, in those individual repositories, but bind them together with linked data so that you can have a source, be able to join those together. And just aligning on terminology, right? Being able to call a thing. If you've got in one silo, it's called foo, and the other one it's called nem, it doesn't matter that the values are the same or vary. You're no longer able to talk about the same thing consistently, and linked data provides a mechanism by which you can do
that. It's probably a good time to open up to the audience. Maybe if you can put your hands up if you have a question and shout them out, and then I'll repeat them for the audio.
I've been working with RDF for a long time, so whenever we were talking about provenance, it was kind of easy to attach it to a product that was being developed from that point on. What do you recommend instead, or along the same lines to do when you already have a lot of processes in place, a lot of operations that are being done, a lot of steps in the lineage, and you want to attach some provenance information, you want to explain what you're doing, especially if it's a really messy and even sometimes hard-coded pipeline.
This is my world. So there are a number of techniques. Sometimes, so in general, manually documented lineage is wrong. So the more that you can automate, the better. The more that you can extract that information directly from the running system, the better. Sometimes you have no choice. Sometimes you have, a script that somebody wrote 100 years ago and no one can understand, and it's a black box. So what you need are a number of flexible rules. What you need to capture basically at there's two levels. One is what should happen, and the other is what did happen, and to be able to correlate the two so that you can discover, wait a minute, we normally have 10,000 records from that source, and today we got 5. There's a problem, right? So the style of the reporting, the way you capture it and things can depend on what questions you're trying to answer, just like with any data problem. But often you want to know what should happen, what's normal, where are the anomalies, and also provide a proof that data at the end is okay. So, at some point, some parts of the processing is very straightforward and you don't need much detail, but others where you're doing complex manipulation, you may be needing to log more. And I think there's a framework for what should happen, and there's a log for what did happen, and a correlation between the two.
Probably to add to that, so the power of linked data standards is that you can start mixing in all sorts of information with your data, right? So you can be looking at, Mandy talked about automation, you can actually extract information about the nodes in your pipeline processing the data. You can start linking that information in. You can look at your requirements. You can start linking requirements information to your data, so on and so forth. And again, we're using well-known, well-documented standards. So for example, if you're linking elements in your data pipeline to specific legislation, I keep talking about regulation use case because it's something fresh in my mind. You can link elements of your pipeline to, for example, unique identifiers in the laws. So EU laws have obviously unique identifiers for articles or for anything within them. So I think that's quite an important thing.
Yeah, maybe what I would like to add is I think a lot of times in my experience people mix the data lineage with the data provenance, and the thing is just looking into a standard for that, like Proven, doesn't always help, because based on the requirements and the type of data you have to understand what does lineage means for you based on your requirements, and then what is the provenance you need to record in order to support your requirements. And for me, like, data lineage is about looking in the data flow activity more, so how the data moves from system to system, from the origin to its destination, while the provenance is more about looking in the processing activities where data are involved, and basically it could get you could get a lot of levels of granularity there you need to record. So you have to think based on the requirements how deep you want to go on recording. And then I think the best way to try to solve this issue is to create a model that correlates lineage with provenance based on the requirements you have. So look both on the data flow activity and how this data flow activity binds to the processing activity of transforming data, let's say. So it's it's like a matrix situation where you have to think of both and create a model that applies for your requirements. And you can start by using basic concepts you would find in the ontology, but you don't necessarily have to go and exhaust the standard because it might get very complicated and you might get issues on providing recording activity and becomes very costly with no reason, for example. So.
Do you want to shout it out, and I'll repeat it as long as it's not too long and I can remember it.
So part of data governance, going away from provenance and lineage for a moment, is also managing the ontologies themselves, the knowledge base that provides that ecosystem for all data to fall in. However, that sometimes can cause tension between different stakeholders who rely on ontologies being constant to a certain degree to deliver application support, to deliver microservices, etc. Now, that's less of a problem if you have application ontologies that have already been talked about in this conference. But occasionally you are met with a large legacy code base that does not have application ontologies whatsoever. What strategies in data governance or ontology governance would you recommend in such a situation?
Sorry, so essentially the question was where you have lots of legacy applications without external kind of available ontologies that you can just use out of the box. Where do you start within? No.
Let's say we're sitting on a bunch of applications and a bunch of ontologies because there is no middleman ontology, application ontology between the two. Whenever the domain ontology changes, the applications all have to be updated. If there's 120 of them, that's all the work. How can we address it without having to rewrite everything to include that application support?
How do you deal with the integration hairball in 10 seconds?
I can start. And so what I would do, I would look for maybe paradigms you can apply in this situation. So maybe looking at how software development lifecycle can help. So ontologies, you can sort of say, okay, it's almost code. If you're using it in your software, it becomes part of the code effectively. You need to manage it as code and apply all the same, life cycle, I guess, steps or parts. So I would try and do that. Second thing, perhaps applying something that linked data set of technologies addresses, I think, quite well. So this addressing the identity and negotiating differences, I guess, right? So just looking at the versioning scheme of one sort of another. I know it's quite general answer, but
So sometimes you have to think about where the churn, what's causing the churn. Is the churn a change in requirement of the consumer, or is it a change in the business need of how the processing should be? And if it's the consumer, if the consumer is the one that's causing the churn, then maybe you need consumer ontologies that map to a common ontology that then maps to the implementation, and you maintain greater stability in the common one, which is controlling your code, and the consumer ones are the ones that change the way that you're presenting what the organization does and how it opens. I think that just gives you a little bit more flexibility to be agile in where you can be, but to create the stability where you have a slower change process around it.
I just realized I think I can add something to the answer. So one, right? But I guess another paradigm that you can apply is this. Somebody called it federal versus state, where you have some parts of your ontology, like Mandy said, very stable, and some parts of your ontology that's change perhaps at different speeds, and then you can version them differently. You can manage them. Well, I guess you manage them in the same way, but the speed of change will be different. Yeah.
Thank you very much.
Okay. Another question? No? Not quite. So I guess this may be more of a personal question for Aaron. Not too personal, don't worry, Aaron. Schema.org is obviously quite a significant undertaking, transnational, involving many, many parties, very complex, unstructured data driven. How does the governance for Schema.org work in a nutshell? So you talked earlier about having a bit of a battle about getting website added as an enumeration for, was it Creative Works or something, or a product type? Yeah.
And that wasn't, oddly enough, though there's many contentious, many contentious vocabulary battles in Schema.org, but everyone said website. Oh yeah, we just missed that. Yeah, add it. So it was like, oh good, I'm so clever. But managing vocabulary changes is a bit messy with Schema, obviously, and it kind of relates to this gentleman's question from before, because it's really, as you have a very highly adopted system, it becomes really disruptive if you make changes. So what they tend to do when they make changes is deprecate a term, but still have it in the vocabulary rather than doing away with it altogether. So I think in a collaborative ontology development process, you just need to be cognizant of the risk and have kind of mechanisms, both formal and informal, to control that change, right? So everyone is quite well aware within the kind of Schema.org development community that there are some pretty big repercussions, both in terms of adding to the vocabulary, but especially changing it.
Any other questions? Yeah.
A question on Schema.org. If I want a bit ontology based on the schema, do the schema has the tools which allows me express my ideas in the schema, like I don't know, meeting, for example, idea of meeting and schema expression, and plus add some additional stuff which allows to be understandable by external, like Google, for example, machinery, engineering. How does it look like if I want express my schema, extend the schema with my ideas? How does it look like in practice? In the implementation, how hard-coded is required? Is it cheap, or is it so-so, or how does it look like?
Thanks. It kind of depends on the viability of the terminology that you're suggesting, that if it's broad-based enough, then it could make it into core or a hosted extension, in which case the process is a little arduous simply because it's community-driven and has to go through a lot of different channels and people have to align. On the flip side, especially if you have an internal application that can use the terminology that you want to develop, you can simply extend that locally with the extension mechanism. And JSON LD comes in really handy here because you can just, ID the term or set the context so that your application is aware of that. So it really is kind of use case driven in terms of which route you go. It's fairly straightforward in either case, but whether you seek to extend the core vocabulary or develop that locally really depends on your use case and the general usefulness of the terminology that you want to extend.
I think the sound of the clapping means we're pretty much out of time. Cool. Okay, big round of applause for